Okay, so let's get started. We're going to be taking a look at how to dial in our speed density tables for a Mustang application. Now, in the last training module, we've prepped our VCM scanner in order to go in and data log some specific channels, namely the AC pressure sensor to be a convert that pressure sensor voltage. There we have our map sensor wired into just temporarily, so that we are able to translate that into a pressure reading, an actual map pressure reading. And then we're going to be doing a ratio calculation between our calculated map and our measured map so that we can repopulate and renormalize our speed density tables here for a Mustang application. Now, I probably don't need to do this for this bolt-on application. If I'm going camshafts, if I'm changing the intake manifold out, if I'm going forced induction, this is an absolute necessity, but for right now, I'm going to just do this for demonstration purposes for our vehicle. Even though I have deleted the intake manifold runner control here and I have basic bolt-on mods, I should find that everything is in relatively reasonable order. Now, I am running a custom VCT schedule. We've talked about that extensively throughout other training tutorials, looking at the VCT scheduling and understanding the custom schedule. I'm calling on 6 map points. So I have shrunk down the number of map points that we're going to be working with here because I have the intake manifold runner control deleted, and essentially it's open all the time. It's making this process a lot simpler. So we're going to go through looking at just maybe 1, 2, maybe 3 at the max speed density calibration for different map points in this tutorial. I'm not going to go through all of them because the process is redundant, but it is relatively straightforward. So we need to be able to lock our map points here. I'll start off at map point 0. We'll go through, we'll drive it, we'll log it, and then we'll take our data and learn how we can use the SD calculator to update the SD tables. Let's just pop in and take a look at a few things here. I need to prep this file so that it's ready to go in and run on map point 0. If we go here to engine and we jump over here, airflow over to variable camshaft, we can call out in the distance tables here so we can lock ourselves into map point 0. Looking at our fuel economy distance table, and we translate that, if we actually use our course calculator, I have this all populated in here. So in our VCT schedule window, I have our custom VCT schedule over here. I have our lookup tables here. The green is going to be the distance tables, translating that to the intake and exhaust pairing events here in the blue and the yellow. So looking at this, if I'm calling out a value of 1, it's going to translate that to a cam pairing of 20 and 0. That's normal, stable, idle, optimal stability type of condition. Even in optimal stability here, if we call out 0, that's going to be translating here into the map to point 1. And if we call out a value of 1, that'll be our map to point 0. And in here, in our eco and drivability, if I call out a 0 in either of these two tables, that'll actually call out map to point 0. So we want to change our optimal stability to 1, and we want to change our eco and drivability tables to 0. So we're staying locked onto mapped point 0. Hope that makes sense. So let's look at this real quick. I'm going to jump in. I'm going to change my fuel economy distance to a value of 0. We'll change these back once we're done. Again, we're just locking this in here so we can stay on a particular mapped point. And we only have a couple map points to deal with, so it shouldn't take too long to do this process. We're going to go into optimal stability. We're going to go from a 0 here to a value of 1. So we have all that set up. So now we should be locked into map point 0. The other thing that you could do here, since the cam pairing at map point 0 is 0, 0, in your optimal power, in order to make sure you're just riding on your mapped point 0, if you wanted to go through and calibrate your speed density for your optimal power modes, full throttle, you would have to go in here and change your actual degrees to whatever that map point calls out. So the intake, you set this to 0. Your exhaust, we'll set this to 0. I'm not going to go through doing the full throttle calibrating and tuning here, but that's going to be what you would do if you wanted to go through and see that process. I'm just going to do part throttle cruise for the speed density calculations that'll allow me to get enough of the data collected to be able to update some things. But technically speaking, you probably use force induction. You would want to check it at full throttle, which would require you to have that specific map point you're locking into, lock out your OP, optimal power here, to that cam pairing. In this case would be 0, 0 for map point 0. So we've set up everything here. I have this file saved as SD Tuning MP0, so I've saved this ahead of time. I'm going to go and do file save, and I've actually saved this file into a folder here into our sample data logs in our course folder. It'll be SD Tuning Demo. So this file will be saved here, SD Tuning map point 0. We'll probably lock it in at 1 and 2 just to see, so you can open those up and take a look just for reference perspective. So we have that file open. Oh, Let's go back in here and open that up. Okay. So we want to go ahead and flash this to the car, but before I flash it, let me jump into the scanner here real quick. Just recall we've created this table overlay in that last training module, and we're overlaying here, and this is going to be this particular table overlay here, this SD error %. This is our speed density table, and specifically the speed density calculator. If we look in here, we go up to edit, we go here to our speed density calculator. That table overlay should mimic and mirror what your SD calculator shows in terms of your breakpoint axes for map pressure and engine speed. Now, we've taken care of that already in that last training module, so you definitely want to watch that. You don't want to skip over that tutorial so we can see all those specific details. So this table overlay here is going to be overlaying, we have our map pressure, engine speed, but in the table cell values. We're going to be working with SD error %. This is going to be taking the difference between our calculated map pressure reading and our actual map pressure reading that we've brought in here to the scanner, and it's going to then tell us what we need to update and change our actual speed density tables by using the speed density calculator at a specific mapped point. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.